So, hello, my name is Grant Altenhofen. I'm a former FLO and FTC judge as well as an alumni. So this is Knox. He's pretty much our mascot for our team, and he is the family dog. And yes, he is part human. That's why he's sitting in the front seat with his seatbelt. So a little bit about myself. My name is Grant Altenhofen, as I've already said, and I've been a part of FIRST for 10 years. And those programs include FLL, FTC, as well as a volunteer for FIRST. And my two main FTC teams being height 8686 height differential and 14522 coxswain robotics. And we went on to actually be nominated for first place overall at the World Championship in 2017 and 18, as well as win the World Championship Design Award in 2019 for coxswain robotics. So next, a little bit of volunteer info. We are actually having more kids participating in First Lego League than First Robotics competition. So we'll need a lot of volunteers, accumulating up to over 7,500 participants between FL, FTC, and FL Junior. So believe it or not, we actually have more robotics teams here per capita than anywhere else within the US. And a cool fact that I always hear is that we actually have more FL teams than Minnesota hockey teams. So one campaign that we started on Team 8686 Height Differential was the Just One campaign. And Just One being that if every volunteer currently can go out and find just one more volunteer to take their place, we'll be able to have a sustainable program for future generations. And so for more volunteer opportunities for FL, FTC, as well as FRC, you can visit hightechkids.org. So a little bit of a short SolidWorks tutorial on part creation. As soon as you open SolidWorks, you'll be visited with this welcome screen. And so this can be really nice. So you can view your recent documents. So say, for example, if SolidWorks crashed or you're resuming a current session, you'll be able to promptly be able to jump right back into what you were working on, as well as recent folders, or create a new part, assembly, or drawing. So then from there, if you exit out and then hit Control N on your keyboard, you'll be prompted to create a new SolidWorks document. So today we'll be working with just a part file, and so you can simply just hit OK. And then next, you'll be brought to this screen. And today we'll be working with just the command manager at the top. It can be a little bit daunting at first, but SolidWorks has a fairly intuitive UI, and some of the more nitty-gritty stuff can be a little complex, but today we'll just be working with extrude base right here. So upon clicking it, you'll be prompted to select a certain plane. So it'll visualize which planes you can select. So top plane, front plane, and right plane are currently available. So we'll just hit top plane and right click, and then you'll be prompted to create a sketch. And you can see within the command manager, you'll have new commands to choose from. So we'll just be focusing on this plane right here. You can hit the drop down right here, and then from there you can go to center rectangle. And then after that, you want to move your mouse cursor over to a certain plane. And so, for example, we're going to use this axis right here, and we're going to right click. And then you can simply just drag where you want to create and how large you want to create your rectangle, and then right click again. And then from there, you can either select a line segment that you want to change. And then after that, you can hit the exit button to exit sketch. And one neat thing about SolidWorks is that it's fairly quick in terms of highlighting certain boxes that you want to use next. So as you can see, we already have the number box right here highlighted. So you can immediately just start typing. So for example, if you just type in 5 within your keyboard, it'll change. And then from there, once you're done, you can go ahead and hit the green check mark. And you can see the feature will be completed. And if we zoom out, you can see the full rectangle. And then from there, you just want to make sure that you save your file. So some judging visuals for CAD design. You want to make sure that you're focusing on component selection and design with the judges, as well as subsystem concept design. And this also includes system level integration. And then there's also test and prototype, but that is done outside of CAD. So sometimes you'll have to jump between your physical robot and your CAD files for going back, and perhaps you came to a prototype and it wasn't testing properly. So a redesign or new subsystem concept design has to be created. So this engineering design process flowchart can be quite helpful for the judges in terms of visualizing how your CAD design is done within SolidWorks. And so one visual that we like to create was a robot poster. So this includes the full robot as well as each subsystem, because as you can see, it can be kind of hard, for example, to see the mineral lift. It's located right here within the robot, but with everything obstructing your view, it can be quite helpful for the judges to visualize each subsystem individually and then combined as one. So if it tickles your fancy, you can also create some cool designs. And so this can be a part of your brand standards within your engineering notebook if you so desire. And like, for example, for the mineral lift system, it can be kind of hard to see it behind the mineral collector system and the lander hang system. So we brought it out here to the top right-hand corner for judges to easily see the subsystem alone by itself. And then another visual that we used were product drawings. So this allowed the judges to be able to see different side views. So like, for example, if we were to only show the front view, it can be quite misleading in terms of what this subsystem looks like for the relic lift. And we also include an isometric view. And then we even create product drawings for the entire robot. So this can be useful for showing how each subsystem integrates or is visualized from different view angles. And then from there, we'd go into SWOT, or strength, weakness, threats, and opportunity analysis. So this can be a great visual for showing the judges how each CAD design integrates with each other and the field. Like, for example, for our relic subsystem, we show off our strengths first. So the unique design approach of being able to grab the relic from the top of the part and then bring it up over the field wall. And then we show off our weaknesses. So for example, we need to have actually all that power out there so a server to reach out. So next is file management. So within SolidWorks, you'll want to make sure that you keep everything organized so that you can work efficiently with each file. So we always like to put the year first. So that way, if we were to move on to another season, that way within 2022, all our files will easily be sorted. Because, for example, if we were to put the date first, as soon as the new year overlaps, the date would no longer become 12, it'd become 1. And then that way files can start to get mixed up. And then next, we'd separate everything with an underscore and the main file name. So in this case, it would be main robot. And then that way, in case we have subassemblies, we can say main robot dash subassembly. And then to keep everything in an orderly fashion, we make sure to add numbers between each folder name. So as your folders start to accumulate, it can be quite daunting to have to look and peck through each folder. So this way, they're all in the same order every time you view them within File Explorer. And especially like this past year, you can tell that remote work can be quite helpful. So hosting files within a server, like for example, I'd recommend using Google Drive. It's been great so far and in the past. And like, for example, one caveat to Microsoft OneDrive is that you actually can't delete files within File Explorer. You have to visit the browser and then you can delete them. So that can be quite annoying, but they do have everything built in, including Word, PowerPoint, Excel, and Outlook. So in case you don't have a Word license, you're still able to use Word for, like, for example, or a PowerPoint for creating robot visuals. And then next, I'll open it up to Q&A. And then I do have some notebook samples because while judging, we'd always make sure to reference back to our notebook for how we used SolidWorks and different subassemblies within the robot.
If anyone has any questions, feel free to unmute and ask them here. You can also ask your questions in chat.
Right, yeah, I saw that, like, all your server hosting stuff. Have you ever tried GrabCAD, and have you had any like downsides with that?
We've never used GrabCAD ourselves, but we have thought of it. But yeah, whatever tickles your fancy, or if you want to pick through.
Right, sweet.
Yeah, I've heard great things actually about GrabCAD.
Yeah, it's worked pretty well for us. I'll look in a drive, but.
And then, like, for example, within our engineering section, we'd make sure to reference each subassembly. And so these renders can be great for having the judge visualize what each subassembly does and what their function is and what they look like on the robot.
How do you order your presentations when you're doing, like, based on what parts and stuff do you go in when you're designing your engineering notebook?
Well, we usually just start off with a template, and usually we'd have a template left over from our previous season. So that way we can go through and just follow the template and just plop everything in together. So making sure that we have each robot overview rendered and displayed. And then within InDesign, we built a script so that way it auto inserts every single page automatically.
Were the parts that you did, were they mostly 3D printed or CNC? How did you actually use your designs?
Sorry, I'm having trouble hearing you. Are you referring to 3D printed parts?
Well, I'm just asking how you used your CAD designs. Were you using them for 3D printed parts, for CNC, anything else? How did you, once you designed them, what'd you do with them next?
Yeah, so actually a lot of our robots were either 3D printed or they were CNC'd. So like, as you can see, certain parts, we had a local machine shop CNC our parts. And so either they were printed out of ASA or nylon 12 CF. And within nylon 12 CF, the CF stands for carbon fiber. And so that's actually carbon fiber infused with the nylon. And so, yeah, it either be CNC or 3D printed.
Did you assemble the robot within the CAD design, or how did you make sure that everything fit within your space?
Yeah, so we'd make sure to have a main robot assembly. So as you can see, like within our main robot, we'd have each subassembly within the main assembly. So we'd make sure that there'd be no interferences between each subassembly and everything fit together well. And so, like for example, at first we had some conflicts with our dual arm subassembly integrating with our drivetrain, where the dual arm would attach to the side of the robot. But then we had these fenders for covering the wheels. They wouldn't integrate with the dual arm properly. So we had to make some, yeah, just counter designs in terms of making sure that the dual arm could attach right here properly to the side of the robot. And then another visual that we use for the judges in terms of conveying how we use SolidWorks and future design iterations was finite element analysis. So that way we could determine if the part wasn't structurally sound. So like, for example, our most recent year that we computed, we used 3D printed drive axles. And so we were able to do finite element analysis on this. And we actually determined that the way we printed it would affect how it performs. So like, for example, if this part is printed in this orientation horizontally, the 3D printer layers would be longest in this orientation. So like, for example, if the part was printed vertically, each 3D printed layer would be quite short. And so that's where we found that there was a lot of stress right here at the end of the part. And sometimes it would even snap, the layers would separate. So having the layers much longer increased the strength of the part. And then some resources for SolidWorks. They do a great job of documenting everything within their webpage for either help. So that way you can break down if you need to find a certain feature and how it works, because there can be either like a building error, or when you go and try and rebuild a feature or boss extrude within SolidWorks, it can have trouble regenerating. So sometimes visiting the help webpage can be very beneficial. And then there's also the forums, if you'd like to consult those, because sometimes either if you have like a very specific question that Google can't quite answer, as well as the first resource library.
I had one more quick question for you. You talked about the finite scale. How did you come across how to execute that evaluation?
So we made sure to actually go back to our design process and reevaluate just what went wrong. And so we'd even go back to the brainstorming session if needed. So that way we determined that based on the fact that how an FDM printer works, we can increase the strength of part and how it interacts with the drivetrain. And then another thing that we'd include within our judging presentation or consulting the judges within the pit were our robot requirements. So that way within SolidWorks, we'd make sure that each robot requirement was met. So sometimes it has to be done outside of SolidWorks, but it can be quite handy. For example, making sure that your robot can fit within the sizing limits within SolidWorks can be quite beneficial in terms of meeting certain rule requirements. So like, as you can see, we'd make sure to document this within our engineering notebook for the judges. So that way, in case there was medium or if it was red, we'd make sure the validation was marked properly.
When do you tend to work on this engineering notebook? Do you start with it at the beginning of the season from your brainstorming all the way up to your competition? Or is there a certain time frame where you like to start working on it so you don't have to go back and change stuff?
So we use the engineering notebook as a tool as we're designing the robot. So we can either consult back to it while building the robot, or if we need to backtrack and maybe reevaluate a certain subsystem, that way we can easily go back and more towards the deadline of the competition, we'd start to focus very hard on the engineering notebook, and like, for example, making sure everything within InDesign properly fits, and like the entire printing process, we'd make sure that everything came out and printed properly, because some of these larger visuals, a lot with how the ink would come out on, like, for example, a product drawing, we'd make sure that everything was printed and the visuals were easily just visualized. Yeah, so if there are no other questions, I'll have to leave it at that. And yeah, thank you very much for watching and listening to my presentation.